Okay, so we have mid-segments of a trapezoid. So let's kind of refresh your memory. We've had the word mid-segment before, and you don't need to write this down. This is more of a refresher. We had mid-segments of a triangle. And what we knew about mid-segments is that they were parallel to each other, that they connected the midpoints of the sides, and we also knew that the mid-segment, so two of the mid-segments, equaled the third side, or the side that it was parallel to. So if this was 15, then this is going to be 30. So two of these equal one of those. Well, now we have the mid-segments of a trapezoid. Excuse me. So notice it does not say mid-segment of an isosceles trapezoid. So it does not have to be an isosceles, so the legs do not need to be congruent. It is still connecting the midpoints. So if I have, excuse me, R, S, T, U, make this M and N, just so we have something to talk about. So if I know that this is a mid-segment, so MN is a mid-segment. And that means I know a couple different things. I know then that M and N are each midpoints. So that means that these two segments are congruent to each other, and these two segments are congruent to each other. Notice I did not put the same ticks because the legs are not congruent. If this were an isosceles, the legs would be congruent, so I could put all of these having the same measurement. Okay? So M and N are the midpoints. I know that MN by definition is parallel to UT. And I know that there is a relationship between the length of the midsegment and its two bases. So I'm going to give this to you two different ways. You could say that the sum of RS and UT divided by 2 equals the midsegment. I can put this in another way. I could say that 2 midsegments equals the sum of the 2 bases. I know that a lot of people generally aren't really good at dividing by 2. Think about what this is. If you are adding 2 things up and dividing by 2, it's going to give you the midsegment. So you can also think of it as the average of the bases equals the midsegment. So that's another way of looking at it. So let's think about that when we are doing some examples. I'm going to start off with just some numerical examples, no algebra. So if I have a trapezoid, and I know that you can either say that that's a midsegment, or it's just going to show you the congruency tick so that you know that these are, in fact, midpoints. If this is 5 and this is 2.5, so how long is X, or how long is the midsegment? So I know that 2 midsegments, so 2 X's, equals the sum of my bases. So 5 plus 2.5. So 2X equals, looks like 7.5. So X equals, looks like 3.25. Do some quick math. Maybe. 3.75. That's why I use my calculator. So 3.75. So let's kind of check it. If this is 3.75, so 2 of these should equal what these are. Or adding these 2 up, dividing by 2 should equal that. Notice my midsegment. Here's my longest base. Here's my shortest base. I know that my midsegment better have a length between those 2 numbers. Okay? Let's do one more example using some algebra. This is going to be example 2. Keep getting crooked. Okay, so we're adding a little bit more difficulty in there. So I know 2 of these, so 2 of my midsegments equals what I get when I add those 2 up. So I have 3x plus 2 plus my 2x minus 4. So I have 4x using the distributive property plus 8. Combining some like terms, I get 5x minus 2. Simplify, moving my x's, moving my 2. So I get x to equal 10. Now, looks good. Let's check it. So if I plug 10 back in, that makes 3 times 10. That gives me 32. If I do 2 times 10, that gives me 20. Minus 4 gives me 16. If I put a 10 in here, I get 2 times 10, which is 20, plus 4. Gives me 24. So this seems reasonable. 32 is the biggest, 16 is the smallest, 24 is right in the middle. I'm going to do the math. So 2 times my midsegment of 24 should equal whatever I get when I add my bases. So 48 equals 48. It checks. So I know x actually equals 10.